Let's pick up with 58. Hold on a moment. Let me enlarge that a little bit. This is a little tough to understand. Wow. I'm not sure I understand this. All right, let's see. If we have some sort of a plane, it's not a solid, it's a plane, and three distinct lines contained within the plane, how many possible distinct regions of the plane may be separated by any such three lines? All right, well, if I drew the three lines like that, I would have four sections.
Yeah.
If I drew the three lines like, well, there's four already. That's six. So if I draw it like that, I can get 6. And notice that if I move that line just a hair, I believe that has to be 8. 1, 2, 3, 4, 5, 6. Let's see. 1, 2, 3, 4, 5, 6, 7. Can I get 8?
No.
I don't think I can get 8. I can definitely get 7. And I don't think I can get 3. Let's see. If those lines are within the plane, that gives you 4. Three distinct lines, meaning I cannot have a line drawn over itself. That would not be 2 distinct lines. So when it says distinct lines, they have to be slightly different. Yeah, I don't know how to get just 3. That would be tough. And can I get 8? Seems like we should be able to get 8. Let's see. That gives us 4. Notice they didn't say straight line, but they mean straight. If it's curved, it's not called a line. So I'm going to go with that as the most you can get. And that's 7. Yeah, I don't think it matters if I do something like this. That's still going to be 1, 2, 3, 4, 5, 6, 7. So that's all this problem requires, is you to just try a bunch of different combinations. Obviously, time is an element, but that's the kind of thing they're talking about. Now, why they gave us 3 answers, I'm not quite sure, but I can't do 3. I can do 4, I can do 6, I can do 7. I can't do 8 either. All right. All right. This is kind of a fun problem. I see this quite a bit on the ACT test. And it's meant to be a really hard problem, but it really is not a hard problem. Let's look at it. Basically, they want to know that if I took consecutive integers through some n and added them all up, and I get 72, can I easily figure out what n is? I'm going to give you a hint. What are these numbers total?
0.
That's your hint. So how far do I have to get to 0?
22.
Okay. So some number before n is 22. Well, what are the next few numbers after 22?
23, 24.
And
25.
those three numbers add to 72. 23, 24, and 25 add up to 72, and we know that these all total 0. That's the key to this problem, is knowing that when you go from minus x to plus x and add them all up and they're consecutive, you're going to get 0. So in order for the sum to be 72, from there to there, it has to go to the third number after 22.
Okay.
Now, if it would have said 71, there wouldn't be a solution. So they had to give us some number that is the sum of either, they could have said 47, they could have said 72, they could have said 23, and then we would only had to go to 23. But they were somewhat limited in what they could present as answers. Okay, you know the difference between median, and mode. Excuse me. Mean, median, and mode.
Yeah.
Okay. If we have a set of 13 numbers, which of the following cannot affect the value of the median? What's the median mean?
The middle number.
Okay.
They're all 9.
Okay, so let's go through each of these cases and see if we can figure it out. Let's say I had a group of numbers that was 1, 3, 7, up to 25. And there's 13 numbers. Well, the median number is which number?
The middle one, so
7th number.
yeah, 7th.
So the 7th number is my median. Now, if I increase the largest number only, is that going to affect the median?
No.
No, not at all. So it seems like that has to be the answer. But let's go through each one of them, because I'm a little puzzled. It seems like J and K shouldn't affect it either. But decreasing the largest number only, why is that not the answer? Notice that if I were to decrease this 25 down to 2, it changes the position of the 7th number.
Yeah.
So decreasing the largest number only could change the median. Increasing the smallest number, same thing. If I make this 1 a 26, then that changes the position of the 7th number. Increasing each number by 10.
it doesn't change the number. It or doesn't change the position. It changes that value of that number. It's
There you go. Very good. That's why that doesn't work. And same thing with doubling each number. It doesn't change the seventh position, but it does change the value of that median. Very good. Good catch. All right, let's see. We need to go to test 3. And we'll start it and see where our beginning starts here. We'll give you a little bit of a break here. Let's see how fast we can go through these easy ones. In other words, normally with students like yourself, where I know you know the easy ones, I would skip straight to 30 and we would work on just the hard ones. But it occurred to me that a better practice would probably be, let's work on speed, not just degree of difficulty. Okay? So do these kind of with the idea of speed in mind. Let me blow it up just a little bit bigger.
It'd be D.
Good.
$18.
Good.
U only. A.
Good.
Would this one be a good calculator one?
Yeah, I was just going to say, if you have your calculator, fine. If you don't have it, you could probably figure it out relatively easy, but go ahead and use your calculator. There's not very many questions that really require a calculator.
Yeah.
In fact, I'm going to guess 70% on this. See whether I'm right or not. Why is that a great guess? Because
the other ones just don't make sense.
Yeah, exactly. It's not 30 or 50%. And if I divide 6, hold on, I did my approximation wrong. Is it 70? In other words, is this fraction 30%?
Yeah.
All right. About number 5.
It'd be D.
Very good. That one was a little tricky, actually. You just had to be very careful, which is the case on most of these. It's all about attention to detail. Might not even need this.
F.
Good. What's true about M and N?
They're equal, or yeah.
Okay.
They're the same angle.
Okay. So what does that mean? So what is M?
115.
So what is O?
65.
All right.
it would be 80 pi.
Good. I should have thought of this before. I think this is actually a great idea to work on time. I've never really known a good way to work on the speed aspect of these tests.
So it'd be 3.
Okay, so C. Remember, what's very useful is being able to subtract from 180 whenever you're doing geometry. You have to do it all the time.
It would just be 115.
Okay, did you figure out this angle and this angle and then this angle?
Yeah.
Okay, so we had 45, we had 70, that's 115, and this happens to always be equal to the sum of these two. So there was a little bit shorter way of doing it. In other words, to figure out that angle, and then to figure out that angle, and then to go ahead and figure out that angle, and then realize, well, now I got to subtract that from 180 to figure out this one. Once you have this one and this one, you know that Q is the exterior angle, and it's always equal to the other two angles, not the one that it's next to. But notice that Q is supplementary to this angle, right? And these other two angles are also supplementary to that angle. Since they're both supplementary to that angle, then Q has to be equal to that plus that.
Okay.
What do we come up with? 115?
Yeah.
There's another theorem that says no matter how many sides there are, the sum of the exterior angles has to be 360. Notice that 115 plus 110 plus 135 is 360. That's actually the fastest way to do it. And this is what I meant, is that it applies to this. In other words, if I have a 6 or a 5-sided figure, and I draw the exterior angles all in the same direction like that, each of those angles added together adds to 360, always. No matter if it's a square, a triangle, or tetrahedron, or, multi-sided figure. You got to be a little careful because there's always a couple of exterior angles. In other words, if I continue that line that way, which is the exterior angle? Is it 1 or is it 2? So that's why I say when you draw all of them, make sure you go in the same direction like I did. Now you can say that the sum of all of those are 360.
Yeah.
Can be, sometimes you get a specific question on that, and plus on this one it actually would have shortened it a little bit. In other words, there's two shortcuts on that problem that can be taken.
Don't you foil this?
You do, precisely. So what's the first term? What's
square root 2 times square root 2.
Which is?
2.
Okay. Notice that the middle term is going to have a square root of 2 in it.
Yeah.
Both middle terms are going to have a square root of 2 in it. And what's the last term going to be?
24.
What's the answer? Has to be D, without doing the middle. The middle is only going to produce square roots of 2. In other words, when I multiply that times that, I get minus 4 root 2. And when I multiply that times that, I get minus 6 root 2. But the first term and the last term are the only integer terms that are going to come from this thing, from foiling it. So I really don't need to foil it completely. I just need to come up with the first number and the last number. Again, they give a shortcut answer to people who know that little trick. In other words, you don't see 26 minus 8 root 2 on there. If 26 minus 8 root 2 was on there, I would have had to foil the whole thing to find out what these middle two terms are going to come to. But by the fact that they only put 126 on there, meant that I could take the shortcut and not actually have to do the O and the I of FOIL.
Yeah.
It's amazing to me, actually, looking at these on how many problems they put on there where there's at least one shortcut and sometimes two. How do you take a binomial term and square it quickly? In other words, what is A plus B quantity squared? And the other one you should memorize always so that you know how to do it quickly is this one. So what's the top one?
Isn't A squared plus AB
plus 2AB plus B
squared.
And this one is the same thing, only the term on the middle is minus 2 instead of plus 2, but it's still plus B squared. Okay? So, if you have these memorized, and like I said, you should, merely because this is an exercise you have to do so frequently. So what does this become when I square x minus 3y?
It would be x squared would be x squared.
What's 2 times x times that, times the 3y?
Is 6xy?
Yes, minus 6xy. In other words, this term right here, my A is x and my B is 3y. So when I go to take 2 times A times B, I get minus 6xy. And again, is all I have to do is the first 2 terms, and it's the only answer on there that has those first 2 terms. So I don't really need to do the last term either. The ACT test has a lot of questions based on what I call number theory. Okay? If I say I have 3 consecutive even numbers, well, I can write them as x, x plus 2, and x plus 4, right?
Yeah.
If I say I have 3 consecutive numbers, I can write them as x, x plus 1, x plus 2. If they're odd, what does it have to be? In other words, here we have x as some odd number greater than 5. What's the next number that's going to come up in terms of x?
7.
That would be the smallest x could be, right? It's got to be greater than 5. So we'll assume that x is 7. Well, what's the next greater odd integer after 7?
9.
And what is 9 in terms of x?
X plus 2.
That's it.
It would be J.
Good. That's pretty good. That's not that easy.
Yeah.
I mean, you got to do a lot of algebra to get to J. See if we can do one more. Oh, I love these problems. These are what I call marble or age problems. The reason I love them is if I had to answer any question and my life depended on getting it right, this is the ones I would pick. Because you can absolutely test your answer to see if it's correct.
Is it B18?
Yeah. How did you do it? You just kind of experiment with some of these numbers? You basically back solved it, didn't you?
Yeah.
Yeah, in other words, you looked at some of the numbers and figured, well, if she's 18, Kyle's got to be 6, and 18 plus 6 is 24. That's correct. So
Yeah.
I would never try to solve this algebraically. I would always try to back solve it, and I would always start with either the second lowest answer or the fourth answer. And there's a reason for that. There's some good probability behind that rationale. As long as I know which direction I'm going to go if I'm wrong. In other words, let's say I started with 9. Okay? Well, if Ann is 9, Kyle would be 3. That adds to 12. I know for sure that she's got to be greater than 9, older than 9. So I know which, I don't have to try 6. I just have to try the next to highest age, 18, and that will tell me for sure what the answer is, even if it's not correct. Let's say I tried 18 and I got a number bigger than 24. Well, now I know I got to have some smaller number than 18 and bigger than 9. It's got to be 12. That would be my answer. So by starting with the second low or the second high on these kind of problems, you ensure that you are only going to have to do 2 trials at most. And that's the beauty of it. You're never going to have to test all 5 numbers. Now, if you can't tell which direction you're going to go, that's a different story, and sometimes that's the case. But with age problems like this, with marble problems where they say, you know, you have 4 more marbles than Bill, and Bill has 3 times as many marbles as Jim, and those kind of problems, you always know which way to go if your first guess is wrong. You know whether you need to increase it or decrease it. All right. got through 15. Good place to stop. Talk to you next week, Mitch.
All right.